saw on your video? What did you see on your video? You watched the video, right? Right?
Yes.
What did you see on your video? Tell me. Let's review what you saw on your video and then move on.
There was a z-scores and area of the, I forget what it's called, the area is the probability.
Right.
Z-scores.
Right. So can you do a problem like this right now? If you would pull out your calculator and your z-table, can you do these problems? Find the probability that z is greater than negative 3.09. And the next one would be find the probability that z is less than 2.11. And the next one is find the probability that z lies between -1 and 2. And the next one would be find the probability that -4 is less than z is less than 1.06. Can you do those right now? Probability z greater than -3.09. How do I do that? What's the game plan when you see a problem like this? You pull out your z-table, right? This is your z-table right here. It comes with negative z's and positive z's, right? So because this says -3.09, I would go to -3.0, which is right here, and then the column for 9. So -3.09 gives me 0.0010. Now this table always gives you the area to the left of what you're looking up. So I'm here. -3.09. This is the z curve. The center is at 0. And this is what I looked up, 0.0010. And that's not the part I want. I want z greater than -3.09. So this would be 1 minus 0.001, which is 0.999. Because the total area under the curve is 100% or 1. Agreed? Yes or no? Let's go to the next problem. Z less than 2.11. So I'm here, 2.11. I want less than. Less than means to the left, right? So I don't have to do any 1 minus because the table gives me the stuff on the left. So this is called phi of 2.11. That means go look up the table. And I did. I will do so right now. 2.1, just like this, look. 2.1 and 1. 0.9826. Understand? So 0.9826 goes here, and I'm done. There's nothing more for me to do because they asked me for z less than. Now, as we said, less than and less than or equal to gives you the same answer because there is no area at 2.11. So if the question was probability z equals 2.11, what would your answer be? 0. Because at any one point there is no area. Area is probability. Follow me? Okay. So this is my answer for this problem. How about this one? -1 less than z less than 2. So I'm here. -1 less than z less than 2. So I'm looking for this area. So this would be phi of 2 minus phi of -1, meaning go look up the table for 2, go look up the table for -1. So what do you see when you look up the table for 2? I'm here. 2.00 gives me an area of 0.9772. So phi of 2 is 0.9772. That's this right here, from here all the way to the end. And then when I look up,
Sorry, can you just show us how you got it, like how you did it on the chart again?
yeah, so I just looked up 2.0. 2.0, and then this is the hundredths place right here. So it's just 2.00, right? So this is the 2.0 that I picked up right here, 2.0. And then this 0 tells me that the second place after the decimal is also 0. So if I were looking up 2.06, I would go to 2.0 and then the 06 column. Follow me? So this one is 9772. So pull out your table and make sure you can see what I'm doing. And then minus phi of -1. So this time I go to -1. And phi of -1 is 0.1587. I look in the very first column because the hundredths place is 0. You see it? So 0.1587. So subtract, and whatever you get here is your answer. It's the difference between phi of 2 and phi of -1. Follow me? If I've confused you, you need to tell me. Yeah.
So you always subtract the
Phi of B minus phi of A every time, where A is less than B. So it's phi of B minus phi of A, where A is here and B is here. It's always going to be the big one minus the smaller one, because the area to the left of the big one will always be more than the area to the left of the smaller one. Everybody okay? Okay. And the last one. -4, which is really off the curve, right? Remember, empirical rule tells us that if you go 3 standard deviations to the left, you've reached the end of the curve, right? So if I'm at -4, I don't expect anything to the left of that. So let me go to my table right here, and I go as negative as I can, and I see that -3.8 is as negative as it goes. And even -3.89 would give me 0.0001, right? So I understand that there's nothing here, nothing, 0. This area is 0. Follow me? And then this one is 1.06. So it would be phi of 1.06 minus phi of -4. Phi of 1.06 minus phi of -4. So let's go look up 1.06. 1.06 gives me 0.8554. And phi of -4 we just said was either 0 or 0001, right?
Wait, why is it 0 again?
Because there's nothing to the left of it, because if you go 3 standard deviations to the left, you should reach the end of your curve already. There's nothing, there's only a very small area to the left of that, and then I'm still yet another standard deviation over. So 0.0001, let's say, even if I take the smallest number that does exist on my table. So I would say 0.8553 is a good answer. Get it? So how do you do that? Yeah.
So for the test, should we use the 0 or the 0.0?
Either one. Only one answer will, I'm not gonna make you choose between 0.8553 and 0.8554. That would not be right. Yeah.
Can you give an example where it's going the opposite direction?
Greater than?
Yeah.
Yeah, sure. So let's say, let me work with this one. I have a greater than here.
No, with like the with both. I don't know how to explain it. You know how like you did the last one? It's like -4 less than C less than 1.06. Can you do it with like -4 greater than Z and greater? Like the other, it's reversed.
Do you mean this? Do you mean this? Probability Z less than -4 or probability Z greater than 1.06? That would be the complement of this. So this would be Z, either Z less than -4, it wouldn't even be the complement of that, not really. And Z greater than 1.06 would be here.
Okay.
So I have to write it as a union because I can't write it in
Right.
just one statement, right? So for this, you would first look up Z greater than 1.06 by looking up 1.06 on your chart. So let's look at that. 1.06 gives me 0.8554. So this area is 1 minus 0.8554. And then this one is still 0.0001. So it would be the sum of 1 minus 0.8554 and 0.0001. Because I would have to add them both up. Yeah.
If it's greater than, do we always have to subtract from that?
Yes. Yeah. Any other questions? Yeah.
So if you had, say, 7,
7.
you would do 0.999 or 1.
Greater than 7 or less than 7?
Greater, Z is greater than 7.
So that looks like this. So for every one of these problems, you should draw the Z curve to see if your final answer makes sense. So Z greater than 7 would be out here. This is 7. And you're looking for what's greater than 7. It's
Yeah.
going to be nothing there. So the answer, probability Z greater than 7 is 0.
Okay.
Probability Z less than 7 would be 0.99999 repeating, right? 0.9 repeating, like that, right?
Right.
Or 1. Everybody get this or not? Feel free to ask me questions. You guys have me in a little room now. You got me. You got me to yourselves. Ask. Let me show you how to do this on the calculator. Right? So you can use the calculator on the test. And on the homework, you will do every problem by hand and check on the calculator. And you will be off in the thousands place probably. Okay? So let's do these same problems on the calculator. And let's see if you're getting the right answer. So the way to do this is to access normcdf. So please go to second VARs, which will bring you to distributions. And then normcdf, left, right, mu, sigma. Let's show you, okay? So let's say I wanted to do, I want to turn the page, so I just want you to be able to write this, and then I'm going to turn the page. Just something that I've done already, so I can check my answer. So let's say this first question right here. Find the probability that Z is greater than negative 3.09. So this would be norm CDF. Left would be negative 3.09. That's the left-hand point. The right endpoint would be infinity, because I'm going from here to forever, right? So this would be infinity. Mu is 0, sigma is 1. So because mu is 0 and sigma is 1, you don't even have to write the 0 and the 1. Because the calculator will assume that mu is 0 and sigma is 1 if you don't put it in. So, let's do it. Second, VARS, which is right here, brings me to distributions. And then normcdf, which is the second one down. Left endpoint minus 3.09, comma. Right endpoint infinity. So any large positive number would do. How about 1,000? 1,000, comma, 0, comma 1. 0.9989. 0.9989. So 0.999 is what I got. So this works. Follow me? How about the next one? I want z less than 2.11. So normcdf, left endpoint minus infinity. So because I'm going from as far as I can go in the left tail. So minus infinity, how about minus 100? Any large minus negative number will do. Comma, right endpoint, 2.11, comma, 0, 1. Let's do it. Second distribution, normcdf, minus 100, comma, 2.11. And this time I'm not even going to bother. I'm going to be lazy, close the bracket, and hit enter. It doesn't matter. It assumes the 0, 1. So 0.9826. And that's what we got. So that's the check. Get it? Let's do it again? Yeah. Second distribution. Normcdf. Hit enter. Left endpoint, minus infinity. So I put in minus 100, comma. Right endpoint, 2.11. If you want to put the 0, comma 1, you can. Yeah.
Will we ever have to put in the 0 and the 1, or?
You don't have to. It'll assume it if you put nothing in.
My question is, would we ever have a situation where it's not 0 anymore?
All the time. Which is my next. I'll keep going. Yeah. This is the most basic case. So this will be the last step of any problem that you do. You're going to bring it down to a z, and then you're going to go finish it up doing what I did here. So this will be the very last step. But the initial problem will be something like the test grades were normal with a mean of 50, sigma 3. Find the probability of getting more than a 65, like that. So it won't be a z problem. You'll convert it to a z problem, and then look it up. Everybody okay with this? What's your question? Miss, are you having issues? Please talk to me.
Yeah, my calculator.
Is it a different calculator? It's a TI-83? 84?
Yeah.
Okay. Anyone else have a question?
Can you show it for the 84? Can I give you my calculator?
Come. It might say left endpoint, right endpoint, or something like that. Okay. So let's do this one. Okay, the first one. So there. So second, VARS, normcdf. Okay, so instead of saying a, comma, left, comma, right, comma, mu, comma, sigma, this is saying what's the lower one. So it's the same as saying left. So minus 3.09, And you're gonna just hit enter and it'll bring you to the next line. The right one is infinity, so how about 100? And mu is equal to 0 and sigma is equal to 1, and you'll hit enter again. Hit enter one more time.
Okay.
Got it? So instead of going horizontally, it's just going vertically. That's the only difference. Okay, what other questions? No? All right. Let's move it on to the next step, which is, what do you do if the problem says something like this? X is normal, mean 102, and comma 4. Find the probability that X is less than or equal to 103. So let me draw this question. X is normal. X is normal. So this little tilde right here is saying X is distributed as a normal curve with mean 102. The first number is always the mean, and the second number is always the variance. Is the variance. Sigma squared. So it has a mean of 102 and a sigma of what? Sigma is 2, right? So I know from empirical rule that if I go 2, 2, 2, there won't be much after that. Agreed? 3 standard deviations on either side of the mean, and 99.7% lies within, right? Yes.
How do you get a sigma of 2?
Because if the variance is 4, then the sigma is the square root of 4, which is 2.
So the sigma is always the square root of the variance?
Yes. So, this is what number is the first question. Stay with me, guys. What's that number right here? 100 and which? I just don't hear you. 100 and what? This is 102. So if I add a 2 and a 2 and a 2, where am I? 108. Yeah, 108. And my question says, find the probability that X is less than or equal to 103. So 104 is here, and it's asking me for less than or equal to 103. This is what I'm looking for. That's the original problem, which I don't know how to do because I don't have a table for something with a mean of 102 and a standard deviation of 2. But I can certainly change it to Z, right? Don't I have a Z formula? Z equals X minus mu over sigma. Remember that? That's the Z-score formula from before your exam. So I'm going to convert this to a Z problem right here. Probability Z, and I know Z is X minus mu over sigma, less than or equal to 103, that's my X, minus mu is 102, divided by sigma is 2. So I get probability Z less than or equal to 1/2, which is 0.5. So you remember what Z means? Z is the number of standard deviations above or below the mean. So this is saying that 103 is half a standard deviation above the mean, which is obvious from looking at the picture, right? So now we draw a Z curve. Let me draw it right under it. The other one was X. This one is Z. And Z equals 0 is in the center, as we know. Z has mean of 0 and sigma of 1. And 1/2 is right here, 0.5. and I'm looking for this area, which is the same area as the question right above it. But now I know how to look it up because I know I have a Z table. Question? It's clear. Ask me.
Yeah, so, okay, so the 102 is the mean, so you put that at the middle of the Z curve, right?
Of the X curve.
Yeah, so that's where that's there. So that curve is the X curve.
Right.
And so then you have the Z formula, and that's how you find out what your Z is. And then you can use that. So I get most of it. The only thing I'm a little confused about is the 3 jumps. That's because those are your sigmas?
Yeah.
Okay.
Yeah.
And what, did you do 3?
So why did I do that?
Just 3, right?
Because that's as max as you can go,
Okay.
and 99.7% lies within those, right?
Mm-hmm.
So for example, if I had said to you, find the probability that X is greater than 110, what would your answer be?
0.
Yeah, exactly right, because it would be 4 standard deviations above the mean, and I already know that there's nothing there. Okay, so let's finish this up. Z less than or equal to 0.5. How are you going to do it? You're just going to go to your table, right, and look up 0.5. Let's go. 0.5. Oh, there's nothing. There's no hundreds place, so 0.50 gives me 0.6915. So this is 0.6915, and I'm done. Right? I could have done it on my calculator. I would have to do absolutely nothing except normcdf. Let's do it. Normcdf. Left minus infinity, because I'm here. Right, 103. Right, it's saying x less than or equal to 103. So the right endpoint is 103. Mu, 102. Sigma, 2. Stick that in the calculator, tell me what you got. Did you get 0.6915? Okay. So on your homework, you would do this, check with the calculator. Do every problem both ways so that your speed increases by hand, and then the calculator can be used on the exam. Yeah.
Are we going to use the Z table, or are we going to just use your calculator? Okay.
You're going to use the Z table because if you just give me this, you will get 0 on your homework. So you need to do this whole problem and check it with the calculator until you are so familiar with it that a wrong answer would be obvious to you, and you'll get there. Follow me. Any question on what I've said? Okay, let's move on along. What if the question said, I have a bunch of grades with a mean of 70 and a standard deviation of 5, and I want to give A's to the top 10% of my class. A's for the top 10% of the class. How do I do it? How should I do this, do you think? I have an X distribution right here. It has a mean of 70. And I would like to know past what grade should be given A's if I would like to give A's to the top 10% of my class. Yeah.
90%.
90% what?
That's where you should start giving people A's.
So you say that this is a 90? How do you know this?
Because 1 minus 0.10 would be 90%.
So that would give me the area here.
Oh.
1 minus 0.10 would give me the area here. Follow? Okay, yeah.
You
What do you-
find the z-score that gives you the 0.9, and use the z-score formula to find the 3.
Yes, I agree with you. So, suppose I were speaking of z. Z equals 0 is in the center. Let's find the z value such that 0.10 is in the right tail, because once I find the z value such that 0.10 is in the right tail, I can always convert that to x. Agree? Because I have a formula that links x and z together. So if I have no choice but to work with z in the beginning, right? So let's take this 0.10, and then I realize that the table works with the stuff on the left side, not on the right side. So I take its complement, which is 0.9000, and then I'm going to look in the center of the z table for 0.9000. And I will see that I see 8997 right here. 0.8997. That's as close as I can come to 0.9000. And it goes with the row 1.20 and the column 08. Let me write here what I'm talking about. So I have a z table. I'm trying to come as close as I can to this, but I see that as close as I can come is 8997, and when I go backwards, I see that that corresponds to 1.2 in the row and 08 in the column. Are you following me?
Why wouldn't you choose the 0.901?
Because 0.9015 goes with 1.29, and that one is further from 0.9000 than is 0.8997. So which one is closer? The answer is this one is closer. Because the other one is 0.0015 away, and this is 0.0003 away. Follow me? So this one's closer. So 1.28, got it? So this number is 1.28. And my job is to convert this number to x now. So just like you said, z equal x minus mu over sigma. This is the guy that's missing. Z is equal to 1.28. Mu is equal to 70. And sigma is equal to 5. So we cross multiply. 1.28 times 5 plus 70 equals x. So 76.4. So everybody who gets 76.4 and above will be getting an A. Get it?
So would you say, is it safe to say that if you were to go on the Z table to find, like how you did for 0.900, and would you say it's better to take a number that's less than?
Not necessarily. You have to see which one is closer, the lower number or the higher number, and then pick up the one. It doesn't matter if it's lower or higher, as long as it's closer. But you're not going to actually use this. This is just the foundation. You're not going to actually do this. I'm going to tell you about the T-table right now. And that's a better way. Okay, was that on your video? Okay. So is this the best way to do this problem? The answer is no. There is a better way to do this problem, but this should be understandable to you given what you know right now, right? Does it make sense? Okay, so a better way to do this problem is to pull out the other table that you were supposed to print for today, which is the T-table. So what is this thing? What is this T-table? First of all, this is a table belonging to the student's T distribution. There was a guy named William Gossett who worked for a brewery and the brewery frowned upon independent research by anybody. So the guy had to hide his research and publish it under the pseudonym student. So this is called the student's tea distribution, not Gossett's tea distribution. And the beauty of this distribution is that it deals with the area, not to the left of what you look up, but the area in the tail. So if you look up this area of 0.10, it will automatically give you this cutoff. Follow me? So what does this have to do with Z? The answer is very simple. The limiting case of T is Z, meaning that if you take the limit as n approaches infinity, that means go to the last row of the T table, these T curves tend towards Z. So let me show you what I mean. This is what a T distribution looks like. It's unimodal, bell-shaped, symmetrical, just like the Z. But if this is Z, oops, if this is Z, then this will be T. The T has thicker tails. But they both have unimodal bell-shaped properties, symmetrical about the mean. So you see this left margin right here where it says degrees of freedom? You remember what the degrees of freedom were when you calculated S? Remember that n minus 1 that went with Bessel's correction? So if you're dealing with say, the T distribution, you would use n minus 1 degrees of freedom because T utilizes S in the denominator, whereas Z utilizes sigma in the denominator. You don't have to worry about all that. Right now, I'm teaching you how to cheat and use the T distribution to arrive at what you need quickly, okay? So, turns out that as the degrees of freedom get larger and larger, in other words, infinity, these two are one and the same. The T approaches the Z curve. That means that anytime I have a question in regards to Z, dealing with area in the right tail, I can just go to my T table, do this, go to the T table, look up 0.10 because we were wanting to give A's to the people who are in the top 10%. So go look up 0.10 and go all the way to the last row, which says 1.282. Remember you estimated 1.28? Remember your estimate here was 1.28? Well, it's not only 1.28, but it's 1.282 is the exact value. Because 1.28 went with 0.8997, but your number was 0.9000. So that is a Z value of 1.282. Yeah.
Why do you go to the last one again? Like, why do you go all the way down?
Because the degrees of freedom are getting larger and larger as you go down the margin, and the Z is the limit as n goes to infinity of the T distributions. So these are all different T curves, but as you get closer and closer to, as you get past 40, these things get closer and closer to Z until ultimately the last value is for a Z curve. They all have the same shape, but it all approaches Z as you get larger and larger and larger, as n, the sample size, gets larger. So don't worry about all that right now. Just understand that every question with Z can be answered by looking at the T table and the appropriate column if it's asking for area in the tail being 10% or 5% or whatever. Yes?
So it's only for the tail part of
Yeah.
the curve?
Yeah. So only when I say what is the cutoff such that, let's say I want to fail the bottom 5%. What would the answer be? I would go like this. I would draw it. I would say bottom 5%, so stick that 5% in the left tail. Go to the T table and look up 0.05. here's 0.05, and go all the way down. And I see 1.645. Except 1.645 would go with this picture. I'm not in the top tail. I'm in the bottom tail because I want to fail my people, so they're poor performers, right? So they're at the bottom half of the bottom 5% of the curve, right? So this would be 0.05 here minus 1.645 for Z. Follow me, because it's symmetrical about 0. The mean is 0 for Z, remember? You good? Are you good? So I need to finish up this problem. Z equals x minus mu over sigma. Z equals minus 1.645. X is what I'm looking for because I want to know where should I cut them off and fail them. After what point should I fail them? On the left. Mu is whatever it was before. It was 70 and sigma was 5. Cross multiply and solve. Minus 1.645 times 5 plus 70 equals x. Follow? So what do you get when you do this? Minus 1.645 times 5 plus 70. 61.775. Or I can use my calculator. How do you use the calculator? Second VARs brings you to distributions. Then you're going to pick inverse norm, percentile, comma, mu, comma, sigma. So if I want to fail 5% of the class, my percentile is 5%, right? P5. So 0.05 goes here. Mu, 70. Sigma, 5. Can you put it in and see if you get 61.775? Any question? So when do you use normcdf and when do you use inverse norm?
Can you only use inverse norm to find the bottom percentage?
No, you can use it to find the top percentage. So if I said to you this question, I want A's for the top 10% of my class, who should get an A? And the answer being 76.4, I would do inverse norm. What percentile are you looking for?
90th percentile.
Exactly, P90. So this would be 90, because this is the 90th percentile. 0.9, comma, mu, comma, sigma. What do you get?
It is 76.4.
76.4?
Yeah, 76.407.
Fine. 76.41. Any questions? Okay, so this number right here, this number is called Z sub 0.10. Z alpha is the value of Z such that alpha is the area in the right tail. So this is alpha. If alpha is the area in the right tail, my alpha being 10%, this is Z sub alpha. And this one, minus 1.28, is minus Z sub sub alpha, because it's just the negation of the one on the right side because of the symmetry. Follow me? So, do you think you could find me z.025? Find me z.025. That means what? It means go to your z-curve, stick the 025 in the right tail, and find me this number. So of course you're going to cheat and use the t-table. Why? Because it deals with the area in the tail, which is the specialty of the t-table, right? Anytime you're dealing with here's the area in the tail, find the cutoff, you have to go to t. So go to t, go to the 0.025, 0.025 column, and go all the way to the bottom. What do you see? I'm here. I'm going to go to 025 column and go all the way down. I see 1.96. So that number is 1.96. So z.025 is 1.96. And this number right here is minus z.025. That would be minus 1.96.
If we're always going all the way down to the bottom, what are all the other numbers for?
It's for later on in the semester when it's not about z, it's about t.
Oh, okay.
And it's going to be about t when they don't give you sigma, but they give you s. So if they don't give you the population standard deviation, you know how I go z equals x minus mu over sigma? That's why it's z. But if it weren't sigma, but if it were s instead, I would be using n minus 1 degrees of freedom based on n, the sample size in that project.
Okay.
So if n were 12, I would use 11 degrees of freedom and then go to the 025 column and pick up this number instead of the number on the bottom.
Okay.
Yeah. Any question? Find me the area on a normal curve with mean mu and standard deviation sigma. Find me the area within 2 standard deviations of the mean. Within 2 standard deviations of the mean. So here's x. I want you to look at 2 standard deviations to the left, 2 standard deviations to the right, and I want this area. Do we already know what it's going to be roughly? Do you have a rough idea of what this would be? If I took away your z-table and I took away your calculator, what would you say to me? Yeah, empirical rule says 95% is the area within 2 standard deviations on either side of the mean. Am I correct? So let's see what my table gives me now. Let's go look up 2 and let's go look up minus 2. So this is actually mu plus 2 sigma, and this would be mu minus 2 sigma. But when I convert it to z, I will get 0 for the mean, a 2 here, and a minus 2 here. Because, let me just do one of them so you can see. When I convert mu plus 2 sigma to a z, what do I get? Z equals mu plus 2 sigma minus mu over sigma. I'm using z equal x minus mu over sigma, right? Look what happens. This cancels with this, and 2 sigma over sigma is just 2. So I'm saying that 2 standard deviations above the mean will bring you to z value of 2, right? So can we finish up this problem? There's many ways to do it. You can go look up 2 on your z table, and minus 2 on your z table, and take the difference. When you look up 2, you're going to see 0.9772. And when you look up minus 2, you're going to see 0.0228. And you're going to take the difference. So, what do you get? Let's see. 6, 4, 4, 5, 9. 0.9544. 95.44% of the curve sits within 2 standard deviations on both sides of the mean. Empirical rule is an estimate. This is the exact value. Follow? So stuff like this is on your first homework. After today's lecture and watching the first video, go back and watch that first video, and after this, you should be able to do the first homework in its entirety. You should be able to do that whole homework. Do it by hand, do it by calculator. Okay, so let me go to the typed notes and continue from there. So you'll see me doing all these problems on page 5 on the first video. Let's do page 7 right now. A large group of women in Chicago is known to have weights that are normally distributed with mean 145 pounds and standard deviation 12.5 pounds. Here we go. X is normal with mean 145 and sigma equals 12.5 pounds. A, what is the probability that a randomly selected woman from this group weighs less than 140? Probability X less than 140. How would I do this on my calculator, first and foremost? What's the calculator command to do this problem?
Second force.
Second. Yeah, that will bring me to distributions. Right? Norm CDF. Go, go, go. Left endpoint. Minus infinity. Right endpoint. 140. Mu. 145. Sigma. 12.5. That should give you the answer. I'm going to go do it by hand right now, okay? You should too. So this would be probability Z less than X, which is 140, minus mu over sigma. This is probability Z less than negative 5 over 12.5. So this is probability Z less than negative 0.4. So let me go look up negative 0.4 on my Z table. I see 0.3446. Is that the answer you got on your calculator? Yes? Perfect. Part B. What is the probability that a randomly selected woman weighs more than 160 pounds? So B, probability X greater than 160. Go, 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 by hand. Probability Z greater than 160 minus the mean divided by sigma. This is probability Z greater than 15 over 12.5, which is 1 And 2.5 over 12.5 is 0.2. Z greater than 1.2. So go here. This is 1.2. I'm looking for this area. I'm also looking for my Z table. Right now, 1.20, 0.8849, except I don't want that part. I don't want the part on the left. The table gives me the stuff on the left. I don't want that. I want this. 1 minus 0.8849. That's my answer. How do I do this on the calculator? normcdf. normcdf what? Left-hand point what?
Take it to infinity.
Left-hand point, why it's saying x greater than 160. So 160 is the left-hand point, right? Right-hand point, infinity. Mean, 145. Sigma, 12.5. What do you get? Let's do it. Second distribution, normcdf, 160, comma, 100, comma, oops, no 100. How about 1,000, comma, 145, comma, 12.5. 0.11, 0.1151, and 0.1151 is what I got also.
It's just almost 1,000 instead of 100.
I used 1,000 instead of 100 because 100 is less than 160 in this problem. So I want to pick something really huge. What confuses you guys? Talk to me. Nothing? How about part D? What weight would be the 95th percentile? So I'm on page 8 right now. This is all on page 8 of the type notes. What weight is the 95th percentile? So by hand, I would do like this. Z. 95th percentile means 5% in the right tail. I'm going to go to my T table, T, look up 0.05, go all the way down to the last row. What will I see?
1.645.
Right, 1.645. That's Z.05. Agree? Remember that the subscript is the area in the right tail. Remember? So I'm not done because I have to change this number to x. So Z equals x minus mu over sigma. 1.645 equals x minus, what's the mean for this problem? 145, and what's the sigma? 12.5. Cross multiply. 1.645 times 12.5 plus 145. 165.5625. X equals 165.5625. That's the 95th percentile. How do I check it? Calculator, what's the command? Exactly. Inverse norm. Percentile. What's the percentile? 95.95. Mu. Was 45. Sigma. 12.5. Hit it on the calculator and what do you get? Did you get that answer or no? 165.561. It works. You're off in the 1,000, right? The thousands, please. Ask me what you don't understand.
Why do you use the inverse
Why do you use inverse norm? Because you use inverse norm every time they give you the percentile and you have to find the cutoff. This is no different than saying I want to give 5% to the A's to the top 5% of my class, where the mean is 145 and the sigma is 12.5. So when they give you the percent and they ask you for the cutoff, it's inverse norm. Get it? Okay, so let's see. I was on page 8. What is the probability that among 10 women selected at random from this population, exactly one will be between 120 and 150 pounds? You should skip part E because this is binomial theorem and I haven't taught you binomial theorem yet. So skip that one. Skip. Until you know binomials. What's your question? Does anybody have a copy of the homework? The first homework? Yeah? Let's pick out a problem from there and do it. Because I would need to start something new right now. Let's do some hard ones from the homework. Does anyone have a copy that I can borrow? Please may I borrow it? Thank you so much. So, let's see. Let's go to the back. Okay. I don't know, these are looking easy to me. How about number 23? Last one. Okay. It says, women's weights are normally distributed with a mean given by 143 and a standard deviation given by 29. Find the third decile, which separates the bottom 30% from the top 70%. Go. Do it the quickest way you know how. Number 23. Mu equals 143. Sigma equals 29. Find the third decile. Third decile means what? What percentile?
0.75.
Huh? Third decile.
Oh.
Decile.
30%.
30%, right. So this is 30.3. Find P30. That's the question. Right? What's the fastest way to do this problem? Yeah. What's the command? Inverse norm what? 0.3, comma, what? Mean, right, so percentile, comma, mean, comma, sigma. So sigma is 29. Oops, there. So let me get an answer and then I'll do it by hand and we'll see what we got. So second distribution in the inverse norm, 0.3, comma, 143, comma, 29. 127.79. Here's 143. And they're telling me that this answer is 127.79. Could be, right? How should I do this if I had to do this by hand, which is your task for your homework? Because I'm not looking to see if you can punch in verse norm and normcdf. I want to see if you can do this. Yeah. How should I do?
Would you look on the T-table?
Yeah, I would look on the T-table for the 0.3 column. Go all the way down to the bottom of the 0.3 column on the T-table. So here I am, T-table, 0.3 column, all the way on the bottom, I see 0.524. But it's, even though it says positive 0.524 here, I am on the left side. I'm here. So this would be minus 0.524 because when I'm at the 30th percentile, I'm to the left of 0. 0 is in the middle, right? So minus 0.524 is z. Set that equal to x minus mu. X is what you're looking for. Mu is 143 over 29. Yeah? Cross multiply. Minus 0.524 times 29 plus 143. 127.80. I got 127.79. Good enough for me. Get it? So all these are doable. I don't see anything super hard on this. How about this one? Number 13. The following density function describes a random variable x. F of x equals x minus 1 over 8 between 1 and 5. So y equals f of x, that's the probability density function, equals x over 8 minus 1 over 8. And it's defined on 1 to 5, on the interval 1 to 5. So this is a straight line, right? It has a slope of 1/8. Y equals mx plus b, right? So the b is negative 1/8. So right here, negative 1/8. And the slope is 1/8. So up 1 over 8. Up, or I can say up 1/8 over 1. Couldn't I? Slope is change in y over change in x, right? So can I say that this line passes like this? And is defined from 1 to 5. And the question says, find the probability that x lies between 2 and 4. Between 2 and 4. So as we said on that video last time, probability equals area. So basically I'm looking at the area between 2 and 4. So it's a trapezoid, right? Area of a trapezoid equals base 1 plus base 2 over 2 times the height. It's the average base times the height. So here's the average base, look. Here's the average base right here. This is base 1. This is base 2. The height, this is a trapezoid turned on its side, right? This is the height, which is 2. And I want base 1 plus base 2 over 2 times the height. Are you with me? Okay, so how much is this base 1 right here? That's the value from plugging in 2 into the function. So I'm going to go plug in 2 into this function. So 2/8 minus 1/8 is 1/8. 2/8 minus 1/8 is 1/8. And then this base 2 is what I get when I plug in 4 into the function. So 4/8 minus 1/8 is 3/8. So now I want the average of those two. So this is equal to 1/8 plus 3/8 divided by 2. So that's 4/8 divided by 2, which is 2/8. It's no brain surgery there. 2/8 times the height, 2. So 2 and 2 cancel. And I get 4/8, which is 1/2. You can do this whole problem on your calculator. Let me show you how. First thing you do is you go to y equals, and you put in the function x over 8 minus 1 over 8. X divided by 8, I should probably put brackets, right? So x divided by 8 minus 1 divided by 8. And then I will go to the window and put in the window that I want, which is from 1 to 5, or 0 to 5, whatever you want to do. So x min is 0, x max is 5, x scale is 1, y min is 0, y max is, let me not say 0, let me say minus 1, because otherwise it'll blow up.